Okay, we're going to try this again. This is the third time, fourth time, fifth time, I don't even know what time. I'm trying to record this lesson for you, so hopefully it will work now that we're using Smartboard. So we have started our fourth unit, which is actually our fourth chapter, and we're looking at scale factors and we're looking at similarity between shapes. This first lesson is just going to look at scale factor, so looking at enlargements and reductions. So your first problem is to draw new pictures with dimensions. And so when I say the word dimensions, what we mean is measurements that are twice as large as the original. So they need to be 2 times as large. So I'm going to pause this and redraw these shapes, and then we're going to use our scale factor. Okay, look at that. Magic. So we have made, we need to make everything 2 times as big. So our measurement that was 10 is now going to be twice as big. So now we have a measurement of 20. And a measurement of 3 is going to become twice as big. So now it's a measurement of 6. Okay, and so on for all the measurements. So all of the measurements have now doubled. And so if we were doing this excuse me, with rulers, you would measure out 10 centimeters and then you would measure out 20 centimeters to show that it had actually doubled. But these are just random units, so it's okay that we just do sketches for this example. All right, for your next example, you have a box with words in it. And so I would like you to take some time and figure out what is an enlargement and how would you describe an enlargement in your own words. So to make an enlargement is to make something larger. It has the word large in it. So you are making something larger or bigger. So an enlargement is when you increase the dimensions, so the length and the width or the base and the height or whatever you want to call it, of an object by a constant factor. And so this means we are going to be multiplying. Okay, so just by adding 1 to the side lengths, that's not an enlargement. An enlargement is actually using a factor, so multiplying each side length by the same constant amount to make all side lengths larger by the same amount, keeping the ratio equal. Okay, so first one we're going to look at is a triangle, and this question is actually asking you to use a scale factor or an enlargement factor of 1.5. Okay, 1.5 times bigger. So that's your hint of what your scale is or how much you need to multiply by. So we're going to multiply each measurement by 1.5. So the easiest way to do this is I'm going to pick a point. That's going to be A, it's going to be B, and I'm actually going to count the squares to figure out how long each length is. So from A to B is 4 squares, B to C is also 4 squares. So when I make my new measurement, I'm going to multiply those side lengths by 1.5 to get my new side lengths. So 4 times 1.5 is 6. So that means now on my new shape, they need to be 6 squares apart. So 1, 2, 3, 4, 5, 6. Okay, so that's where the new B is going to be, and B and C also need to be 6 squares apart. 1, 2, 3, 4, 5, 6. Okay, and so then all you need to do is take your ruler and connect your dots. Okay, and so then you have a new triangle with the enlarged measurements of 6 and 6. So what your job will be is to do the same thing for the L and the M, and then we will check those together in class tomorrow. Okay, so the next thing we need to do is we need to talk about reductions. And so again, you have a box, you have boxes with words in them. So take a minute to figure out how you can describe those words in your own words. All right, so hopefully you figured out that a reduction is the opposite of an enlargement. You are making a shape smaller, or you are reducing it. And so you were reducing or decreasing the dimensions of an object by a constant factor. So it is still utilizing multiplication, You will still be multiplying by a factor, but now the factor will look a little different, and we'll talk about that in a minute. And so then the next one we need to talk about is scale factor. So we've been saying for an enlargement and reduction that you need to use a constant factor. Well, the scale factor is that constant factor. So it is that amount that you are multiplying your shape by or your object by to make the enlargement or reduction. So the scale factor is that magic number. In the last example, it was 1.5 because we were making everything 1.5 times larger. So when we look at these examples, it says draw a reduction in which is half as large as the original. Okay, so half. So when we think of half, we think of dividing by 2. But in order for a scale factor, we need to think of multiplying. So we need to think of multiplying by 1/2. Okay, or you could think of it as multiplying by 0.5. So we could think of it as a decimal as well. So when we look at the first shape, again, we're going to identify some corners. So A, B, C, D, E, and F. And the first measurement I'm going to look at is from A to B. And A to B is 4 squares. And so I need to think of multiplying my shape by half. And so the measurements are going to be cut in half or divided by 2. And so A to B is now only going to be 2 squares long. Okay, that length is only 2 squares long now. The next length we're going to look at is I'm actually going to look from B to D to see how tall my shape is. And so it is 1, 2, 3, 4, 5, 6. And so now in the new shape it needs to be half of that. So it's only going to be 3 apart. So 1, 2, 3. So that's where the new D is going to be. So that means that's where the new E has to be. Okay. The last 2 points we need to figure out are C and F. And C is halfway between B and D. And so that means it needs to be halfway between B prime and D prime on our new shape. The other thing we need to look at is, well, how far away is it from B this way to the side? And it's 2 squares to the right. So half of that is only going to be 1 square to the right. So in our new shape, it needs to be halfway between B and D, which is about there. 1.5, and it needs to be 1 square to the right. And so that means F has to be the same height and 1 square to the left from A prime. And so then that is our new shape. Using our ruler, connect your spots. There's your new hexagon, more or less. And so again, you're going to use a scale factor of half, and you're going to make the arrow half as big. And we'll check that tomorrow. Okay, so a couple rules. You might want to star these and just kind of to help you remember. The nice little thing to help you remember is that if you have a scale factor that is greater than 1, so larger than 1, you are going to get an enlargement because you are multiplying it by something bigger than itself. And then, so if we're multiplying by a scale factor that is less than 1, so it's either a fraction, a proper fraction, or it's a decimal with no whole number, you are going to make a reduction. Because you are multiplying by less than itself. And so the last one says a scale factor that is equal to 1. So if you are multiplying something by 1, right, you think 5 is 1.
Meetings are starting down in the learning resource.
Okay, so it makes an exact copy. So by multiplying by exactly 1, you make an exact copy. Oh, that should be a P, not an R. Okay, and so the last, so we've got A to A prime, B going to B prime, C going to C prime, and D going to D prime. So first thing you need to decide is if it's an enlargement or it's a reduction. So I'll do A for you. It's getting bigger, so it is an enlargement. And then you need to decide what is the scale factor. So how much bigger is it? Well, In order to turn 3 into 9, I need to multiply by 3. So it is a scale factor of 3. Looking at the second one, it's going from big to small, so it is a reduction. It's getting smaller. And the scale factor, so my scale factor has to be less than 1. So I have to go from 12 to 3 and 8 to 2. So I know that means I have to divide by 4. And I need to think, okay, well, what could I multiply by that's the same as dividing by 4? Well, 8 times 1 over 4 is the same as 8 over 4, or 8 divided by 4. So our scale factor is 1 over 4, or we could put it as a decimal, 0.25. Okay, so C prime, C to C prime, D to D prime, you're going to do those on your own as well, and we are going to check those in class tomorrow.